Hey everyone, welcome back. So in the last video, we understood what is pod, why Kubernetes use pod, and the difference between a pod container and the virtual machines. So in this video, we will understand what is the single container pod. We will also write the first YAML file. We'll run it on the real Kubernetes cluster. We'll check the pod status and we'll go inside the pod and we'll finally delete the pod. So let's get started. A single container pod means one pod contains one container. So your application run inside the container and Kubernetes manage the pod. So this is the most common type of pod used in the Kubernetes. In the most real world applications, one pod usually contain one container. So before we go hands on, let's understand the YAML file which we are going to create. So in the Kubernetes, we use the YAML file to create and manage the resources. This YAML file is called manifest file. So let me explain every single line. So first we have API version v1. So this tell Kubernetes which API version we are using. For pod, it is always v1. Second, we have a kind is equal to pod, and this tell Kubernetes what we are going to create. In this case, we are creating a pod. Third, we have a metadata. Metadata is the information about the pod, and within the metadata, we have a name is equal to my first pod. This is the name of our pod, and then we have labels. Labels are the key value pairs that we attach to the pod, and we will use this later for the deployment and services. Fourth, we have a spec. This is the actual specifications. So within the specs, we have a container. This is the list of the container that we run inside the pod. Then we have a name is equal to my container. This is the name of the container. And then we have an image is equal to nginx. We are using nginx web server docker image. And we have a container port is equal to 80 and the port on which container runs. Now let's run this practically. So for this hands-on practice, we need a real Kubernetes cluster, and we will use Killercoda website, which will give you a real Kubernetes cluster directly on the browser. No installation and no setup is required. Now, if you are using a Killercoda for the first time, you need to create a free account. So now let's open the killercoda.com, then click on the Kubernetes scenario. Select the Kubernetes playground or CKA playground, and your Kubernetes live environment will be ready in few seconds. Wait for the environment to load. Once it loads, you will see the terminal with real Kubernetes cluster ready to use. So let's verify the cluster first, and to verify it, we run a command called kubectl get node. And if you'll see, control node plane and node 01, and both are in ready state. So first we will create the pod YAML file. So in the terminal, we need to just type vi my first pod. Now press -i to enter into the insert mode, and then copy or type the following YAML file. Now press escape and then type :wq and press enter to save and exit. Now let's verify the file if the file has created correctly. So we will use a command called cat and the my file name, and we will verify the file. So that looks correct. Now let's create the pod. So create the pod from the YAML file. We will run kubectl apply -f and then file name. So our pod has been created. Now let's check the status. And to check the status, we'll run a command kubectl get pod. So first we have a name, that is name of the pod. So ready 1 by 1 means one container is ready out of total 1. And if you see 0 by 1 means the container is not started yet. Wait for the few seconds and run the command again. Then we have a status. Running means our pod is up and healthy. Then we have a restart is equal to 0, means container has not crashed or not started, and A is how long that pod has been running. Now let's get more detail about the pod. So to get more detail about the pod, we will run command kubectl describe pod and then pod name. So we'll just copy and then paste. This will give you a very detailed information about the pod. So we have a node sections here where we can see the node, in which node it has been deployed and what is the node IP address. Then we have a label, annotation, status, and you can see the IP address of the container. Then you can, in the container sections, we can also see container ID, image ID, then image port. We can also see the event section at last. You can see Kubernetes schedule the pod on the node, Kubernetes pull that nginx docker image, Kubernetes created the container, and Kubernetes started the container. And this is the complete journey of our pod from creation to running. Now let's check the status of the container by running a command kubectl logs my first pod. This is extremely useful in the real life when the application has an error and you check the log first. If you want to follow the logs in the real time, you can use a flag called -f. Now press Ctrl C to stop following the logs. Now let's go inside the pod like SSH into the server. So we'll use a command called kubectl exec -it my first pod and -fn bash. So now we are inside the pod. So let's check the default nginx space, and to check it, what we'll use curl command, curl localhost and port 80. We'll see the default base of the nginx which is running on port 80. Now let's exit from the container. Let's see the IP address of the pod, and to see the IP address of the pod, we can run a command called kubectl get pod my first pod and then -o wide, and it will give you the IP address of the pod and on which node our pod is running. And finally we can delete the pod by using a command kubectl delete pod and then pod name, and your pod has been deleted. So we can verify by kubectl get pod, and you can see there is a no port found in the default namespace. We can also delete the pod by using a command kubectl delete -f and the file name. But you see the pod not found because the pod already has been deleted using the previous command. So both command works in the real life. You can use YAML file methods. So now let's quickly recap. A single container pod means one pod running one container. Everything in the Kubernetes is defined using a YAML manifest file. API version and kubectl tell Kubernetes what resource to create. Metadata define the pod name and labels. Spec define which container should be run inside a pod. Then we have also explored some of the kubectl command that every Kubernetes engineer should know. So kubectl apply -f to create the pod from the YAML file. To kubectl get pod to check whether pod is running. Kubectl describe pod to view the detailed information about the pod such as event, node detail and IP address. And kubectl logs pod name to check the container log. Kubectl logs -f pod name to stream the live log in the real time. Kubectl exec -it pod name -fn bash to enter inside the running container similar to SSH. Kubectl get pod -o wide to view the networking and node informations. Kubectl delete pod name to delete the specific pod. And finally we have a kubectl delete -f file name, another way to delete the resources using the YAML file. So in the next video we will learn about the multi-container pod. Thanks for watching and I'll see you next video.